Okay, hi. I'm Aryan. I've been doing CP for a year. So today we're gonna go over week 3 of the DSA Learning Series, which was about C++ STL. So I'll just share my screen and show you the plan for the session. Okay. So um, this is the plan. Okay. So first we're gonna do some theory, and in theory we're gonna cover these 7 containers that you can see here. Okay, then there are 6 problems in the contest in week 3. So we're going to cover these 4 problems, which each look at unique containers. Okay, so that's the plan for today's session. So I'll just get started with the first container, which is map. Okay, so map is similar to an array. Okay, so map is a data structure which is similar to array in the sense that it stores key value pairs. So what that means is the way map is defined is we use map key type, value type, and name. Okay. So for example, if you were to declare an array of type int, you would say something like int array, right? Let me actually switch to, yeah. Okay. So a map is defined in this form. Okay. Now, if you were to declare an array of the same type, you would probably say something like this: int array. Okay. Now there are advantages of a map, right? The advantages of a map are the key can be of any type, and it only uses memory for the number of values inserted. Okay, so the advantage of a map is that it only uses memory for the number of values inserted, and the key can be of any type. So, for example, if you wanted to keep a map, let's say, if an array of type Boolean, okay, and of size, let's say, 10 to the power 9, okay, and the function of this array was that you had to set certain values to true and false. Okay, so you had to set certain values to true and certain values to false. Okay, I'm giving random values right now. Now the problem is that this will consume a lot of memory because it will allocate 10 to the power 9 spaces. Okay, now let's say you had a problem where you only had 10 to the power 5 queries. Okay, so in reality you are only using 10 to the power 5 variables. However, because of the constraints, it is creating memory for 10 to the power 9 variables. Now, if instead of the array you used a map, okay, you could do name int 10 to the power 9 is equal to true, okay, and so what this does is that these 3 lines have used 10 to the power 9 variable spaces, and over here we only created variable space of 1. So we can see that map is more efficient in terms of memory. Okay, and the second advantage of a map is that the key can be of any type. Okay, so let me give you guys a sample problem. Let's say the problem is that um, you you have a queue. Okay, there are people entering and leaving the queue. You are given the names. Okay, you have 10 to the power 5 queries. Okay, there are 2 types of queries. um, Type 1, a person named X is entering the queue, and type 2, um, how many people are there with name X in the queue. Okay, now the name or string types. Okay, so if you try to do this with an array, you would have to use a complicated function like hashing. But with a map, it would be very simple. So for example, sorry, I'm just inputting the number of queries, okay, and inputting the query type, okay. So we could just create a map of the names, okay. So the key type would be string and the final type would be int, and the default value for int values are 0, okay. So type 1 means a person is entering the queue, right? So string name, let's take it, and all we would have to do is we would increment the number of people with that name in the queue, in the map, sorry. And otherwise it's a type 2 query, and for that all we would have to do is output the number of people with the name that are in the queue. Does that make sense? Siddhant Bansal can mention that an unordered map in this use case will do hashing, whereas a map will do comparison with BS. Okay, yeah, Siddhant, I'll just go over that when I'm doing unordered maps. I'll compare back. But thank you. Okay, so now I'm going to move on to the second container, which is set. Right. So that's the function of a map. Okay, I'll move on to set now. So a set, Navjot, we're not discussing a question. We're just going over the theory right now. Okay. So I'll move on to the set now. Okay. So set is a container which is similar to a vector. Okay. Now there are a few differences. A set only stores unique elements. Shubham, no, a map does not use hashing internally. An unordered map uses hashing. Okay. Yeah. So a set stores only unique elements in the container. Okay. So if you were to do, let me work. Yeah. Okay. So if you were to do set.insert5 and set.insert5 again, okay, then the set would only store one variable with value 5, whereas if you had vector int v and you did v dot pushback 5, then the vector would store two variables with value 5. Okay, so that's the first difference. The second difference is that the values in a set are always sorted. So if you did set.insert5 and set.insert4, okay, then let's look at both of the different outputs in both. So a set will probably print it in a sorted order, okay, and the vector will not change the order. Right. Let's just look at the output. Right. So if you see, the set sorted the list in order 4, 5, whereas the vector in the vector it remained in the original order, which is 5, 4. Okay. Harish, does the map also store duplicates? Harish, in a map, duplicate doesn't really make sense because it's a key value pair, right? So I mean, each key has a value, and you can make the value whatever. But obviously, like a key can't have two values in a map still. Yeah, Shubham. Okay, I was going to cover this. So vector insert is order of 1, whereas set insert is order of log n. Okay. Shaker, how internally is it working? It's probably too complicated for this one, and even I don't know that well, so I won't cover it right now. Right. But you don't need to know its internal workings to actually use it in the problem. Harish, duplicate keys. Vector pushback only. Yeah. Harish, what do you mean by duplicate keys?
Hi, Aryan.
Yep. Hi.
Does map allow to multiple duplicate keys? I am asking. I heard somewhere it will allow one duplicate key in map.
No, I've never seen a map use like separate values for same key, right? Like you should think of a map
That's
as like an array only, right?
yes, yes. Okay,
Okay, you get what I'm saying?
okay. Yes.
Okay, I'll move on with set then. Okay. Um. So vector pushback is order one, set inserted log n. Okay. It stores in sorted order. Fine. So let's look over the use case for set. Okay. So let's say you have a 10 to the power 5 queries, right? You have two queries. Insert an element into a set. Wait. Type 1 query is to insert an element into the set, and type 2 query for an element x, um output the first element greater than or equal to x in the set, output -1 if no such element exists. Okay. So in the type 2 query, we'll look into an important function of the set as well. Okay. So I'll just answer the chat queries after this. So I'll just show you how to code this. Right. So if it's a type 1 query, then all we do is, let me just remove all of this. Right. So if it's a type 1 query, then all we do is set.insert x, right? Now, if it's a type 2 query, then we're going to look into two important functions of set: lower bound and upper bound. Now, these are both kind of binary search functions, but but they're still important, and we've used it in the um, problem set. So I'll go over it. So s dot lower bound x returns an I sorry returns an iterator to the first element in the set greater than equal to x. Okay. And s dot upper bound x returns an iterator to the first element in the set which is strictly greater than x. Okay. Now, in both of these cases, if no such element exists, they return an iterator to s dot end. Okay. Now, this is also an important topic. S dot begin, okay, is an iterator to the first element in a set. Okay. S dot end is an iterator to the position after the final element of the set. So if you had to access the final element in the set, you would have to do something like minus minus s dot end. Okay. And s dot end is a position that doesn't store any element. So so if there's no such element for either of these two functions, it returns it to this location. Okay. Let me see the zoom. Okay. So Siddhant is helping with the chat, right? So in this problem, we need to return the first element greater than or equal to x, right? So we'll use the lower bound function here. So we can say auto it. So sorry, with iterator, there's a very complicated declaration. Okay. So what auto does is from your what should I say, from the line of code, it deducts what variable it should be, and it just assigns the variable automatically. Okay. So in this case, we would do auto it is equal to s dot lower bound x, right? And yeah, so auto automatically comes an iterator on the set s. Now, if it is equal to s dot end, it implies that there's no element that fits our constraints. So you can simply output -1. On the other hand, if there is an element that fits our constraints, then we have to output the element which is at the position it. So the way you access the element at an iterator is by using the star operator. So you just do star it endl, right? So in this way we use set to solve the problem. Now you would ask maybe why we can't use a vector, right? Why we couldn't do vector int v and use the exact same functions. The problem with this would be that um, a vector doesn't sort the elements, so lower bound, upper bound operations are not possible. Uh, Lower bound, upper bound operations are based on binary search only, so they require a sorted container, right? And a vector doesn't sort automatically, so this wouldn't be possible. Okay. Now, there's also one more thing I've seen people try. So in vectors, you can do something like this. If you have a sorted vector, then you could do like v dot lower bound, sorry, lower bound v dot begin, v dot end, and q, let's say, and sorry, uh, to find the position of q in the vector, you could do int position is equal to it minus v dot begin. Now keep in mind, this trick does not work in a set. Okay, this trick only works when you have random access elements. What random access means that you can do v5 is okay, and you would returns the element at the 5th position. S5, you can't do this. It doesn't work, right? So this doesn't mean anything. A set, you can't access elements randomly. You have to access them in order using iterators. Okay. So I think, yeah, that's enough for set, I think. So I'll look at chat queries for this. At Stark, yes, that's what it does. Okay, great. So I'll go over the next data structure now. Okay, priority queue. This is important. So let's say I give you this type of problem, right? You have 10 to the power 5 queries of 3 types. Okay. Type 1, insert an element into a list. Type 2, answer output the largest element in the list. And type 3, remove the largest element from the list. Okay. Now, if you did this with a, let's say a vector, okay, vector int v, okay, okay. So a type 1 query would be to insert an element into the list, which you could do with v dot pushback. Okay, sorry. V dot pushback x. Okay. So you've inserted the element into the list. Now for queries of type 2, this would be more difficult because you have to output the largest element in the list. Now one way to do this would be like output iterate over all elements in the vector and do and find the max. Okay. Now this makes it order of n, right, which is too large. Okay, now another option is that every time you insert an element, you sort the vector again. Then again, this is an order of n log n thing, so it's again too large. So the way to solve this would be, now if it was only these two operations, then you could simply just keep a max variable outside, right? And every time you could do max equal max maxi x, and over here you could just output max. The problem is that there's a third operation where you remove the max element, and there's nowhere to keep track of the second last, third last element like that, right? So for this, you would need another data structure, and in this case, the data structure which you would need would be a priority queue. Now, what a priority queue does is what a priority queue does is pq.stop top returns the maximum element in a priority queue. Okay, and pq.pop removes the maximum element from the priority queue. Now, this operation works in order of 1. This operation works in order of log n, and pq.push adds an element to the queue. This also works in order of log n, okay? And just for reference, this is internally stored as a binary heap, okay? So if you were to use a priority queue on this, you would simply do pq.push x, pq c out, pq.top, okay, and pq.pop. Okay, now you see that our complexity earlier, it was coming like order of q dot n. Now we've reduced this to order of q log n, right? Yeah, Neil, set should also work for this question, but priority queue is kind of faster. Now, priority queue you might also want to use to store the minimum element, right? So for that, you use a different declaration of priority queue. I'm not sure if I remember this. Let me try. Wait, just give me 1 second. Siddhant, do you remember the template for minimum priority queue? Yeah, okay, that makes sense. Yeah, so again, this is just about memorizing it, I guess. There's no real logic you'll understand, but it's if you want to store the minimum, then you do something like int vector int greater int, okay? And it could be possible that you don't want of type int, so whatever it is, you can make it pair int instead, which is used in another algorithm, okay? And instead of storing the max, this stores the minimum, okay? Yeah, this is accurate. Okay, great. So does anyone have any queries regarding priority queue? At Rakib, that's just the declaration. It's like I don't know the exact logic behind it, but that's the template for making a minimum priority queue. Shubham, how will we store for class type? I think you have to make your own comparator then for the class, and it works, right? Devansh, please explain the function again. Which function are you talking about, Devansh? Okay, Shekhar, implement min heap using STL. Let me take a look. Yeah, so this is accurate only, Shekhar. What I've written is right. This would be for a min heap. Okay, I'll put the code into the chat if you'd like. Okay, Arpan, could you give one more case of priority queue? Arpan, we're solving a problem on it in a few minutes, so you can just see that, right? I've put the code for the min priority queue in the chat. Okay. I'll move on to the next template and next container, sorry. So audit set. Okay, so this is slightly more complicated. So audit set is a part of something called PBDS, which is uh, policy based data structures. Okay. Now let's compare a set to audit set. So in a set, we discussed that there was no random access, right? So if you wanted to know the kth largest element in a set, you would have to iterate through k elements. So let's say you have again n queries, q queries, okay? The queries are insert an element and find the kth largest element in the set. Now, in a regular C++ STL set, this wouldn't be possible because finding the kth largest element would make it order of k into q, which would become order of nq, which is too large. Okay. So instead, we have to use a data structure called ordered set, which can find the kth ordered set can find the kth largest element in order of log n. Okay. Now the declaration for ordered set is a little complicated. So this code here, this is what you need to use to declare an ordered set. It's really complicated to write every time, so most people just include it in a template like this. Okay, but yeah, this is what you would define it as. I've already included my template, so I just define it as o set s. Okay, can I make the comparator as we do in sorting, right, Aryan? Shubham, yeah, I think that should be fine, but I'm still not entirely sure. So I'll look into it after this session. And is this PBDS available in other languages? In Java and all, I'm sure there are classes because internally it's stored as a balanced binary search tree. It's a yeah, it's a balanced binary search tree, so it must be available in Java and all. But I'm just doing it in C++ right now. Okay. So we have O set S. Now we have Q queries, right? So in type and X. Okay. So if type is equal to 1, then we need to insert an element into the set. So the syntax should be simply s dot insert k. Okay. And else if the type is 2, then we need to find the kth largest element. So okay, let's do kth smallest because that's easier. So the syntax for this would be, so kth would be 1 based indexing, right? So the first smallest element would be at index 0. So to make it 0 based indexing, I'm just doing k minus minus here, okay? And then all we would have to do is s dot find by order k. What's going on? Okay, I think it's an iterator, right? Yeah, okay. So find by order returns an iterator. So I'm just accessing the element using the star operator like we discussed earlier. And yeah, so this is the entire code using ordered set. So in ordered set, you can do one more thing. So there are two main functions of ordered set. Okay. First is find by order, which returns the element at the kth position. Okay. And the second one is order of key. This returns the position of the element. So if I did, okay, let's say we have a set which stores the elements 4, 6, 8, 9. Okay, so find by order 1 would return 6, and order of key 6 would return 1. Okay, please zoom the code. Okay, is this readable? Yeah, so that's the concept of an ordered set. Okay, now this part of the code is quite complicated to remember, so usually just copy paste it. If you're going for some competition, then you would have to remember it only, but I'll paste it into the chat now, right now, so you can keep it. Okay, now I'll move on to the next one. Unordered map, unordered set, multi-set. Okay, so I'll just brush over these quickly because they're usually multi-set is important, but otherwise they're usually less important than others. So ordered set, unordered set is like a set, but the elements are not sorted. Okay, the difference between a vector and unordered set is that it only stores unique elements. Okay, then why to define it by OSEC, directly define it by does ordered set accept duplicate elements? Okay, Anurag, good question. Let me go back to ordered set then. So in ordered set, duplicate elements you can't actually store directly, but if you wanted to store duplicate elements, then you would have to store pairs. Okay, and you could keep something like this. So map int count. So map I stores the number of elements uh, I in the set. Okay, okay, so let me just rephrase this. Map stores the frequency of number I in the set. Okay, now a set innately it does not store duplicate elements. Okay, but if you want to store a pair, you can do something. If you want to store duplicate elements, you can do something like this. O set s, and you can do set dot insert. um okay, let's say you have to insert int k, then you would do something like insert pair of k and count k plus plus. Okay, so that's how you store duplicate elements in a ordered set. Is that clear? Shaker, how many keys are allowed to be stored in a map? You can store as many keys as you want, Shaker, as long as you don't exceed the memory limit. Then Shubham, so how will we search an element in O set? Will we have to use O and search multi-set? Rakib, again, an example for this duplicate is there in the problem, so we look over it there. I'm just giving a broad overview right now. Can we store 10 to power 20 keys in a map? Like theoretically, you can store 10 to power 20 keys, but it'll take way too much memory. Okay. Shubham, how will we search an element in an ordered set? Okay. So let me just make this an int again. 1 second. Let me just actually put this link in the chat as well. Yeah, cool. Okay, so this is a 1 second. Siddhant, you know what the issue is here? I'm not sure. Okay, yeah, it's fine now. Okay. No, again. Siddhant, you know what the issue is? I'm quite uncertain. Hmm. Let me try declaring it directly. One second. I'm just trying to sort out a bug. Oh, right, of course. It's a template. Okay, yeah. So this is the set. I'm so sorry for the delay. So you want to know how to search for an element, right? Who said? Um, okay, Shubham Singh said, how will we search for an element in an O set? So by search, do you mean how do we find if an element exists? Shubham, could you just clarify your question once? Navjot, again, the time complexity of finding element in O set is log. Okay, fine. So how to search an element? Okay, I got your question. So you already have the map count, right? So um, whenever you want to search for an element, so let's say you did s dot insert make what s dot insert pair this is what we had earlier, right? So now if you want to search for an element, you could just do something like uh, int uh, x is equal to order of key k, and then you could do something like s dot order of key k and count k minus 1. Does that make sense? Because you know that you've inserted up to count k elements, and so you're searching for the last one. Or you could do something like k0 only, that'll give you the first one. Sayam Kumar, sir, can you tell me? We're just doing theory right now. We're not doing a question yet. Okay. So unordered map. Okay. So unordered map would be something like this, and it works very similarly to a map. The difference is that theoretically it has order of one operations, while map has order of log n operations. Okay. It uses hashing to store keys internally. Okay. However, personally, I'd recommend, Siddhant, tell me if you disagree, but personally, I'd recommend that you don't use unordered map. The reason is that order of one is not accurate because it has a lot of overhead. Okay. Then hashing can usually be hacked to become order of n, so it's unreliable. Okay, on the other hand, map is consistently order of log n. Okay, so in a problem where the time limit is very tight, you can try to use unordered map instead of map. Usually it's not recommended. Okay. Oh yeah, exactly, you're right, Siddhant. Like for int, I mean, there's pretty much no hashing required, but for pair intent strings and stuff, unordered map is very, very unreliable. So use map only. I don't recommend you use unordered map. Okay. Then what was next in our plan? We had unordered set. Okay, so again, unordered set, I haven't really seen many problems which require it, but this is the definition. So unordered set is similar to a regular set in the sense that it stores unique elements that are not randomly accessible. However, um, the elements in an unordered set are not sorted. Okay, so it's basically like a set where the elements aren't sorted. Does that make sense? And I personally don't know any use case for this. I've literally never used it. Okay, so that's unordered set. And finally, multi-set. Shubham. So this, yeah, this remain in order of insertion. Then finally, we have multi-set. So multi-set again, it's similar to set. Um, multi-set is similar to set that it stores elements in a sorted order and the elements are not randomly accessible. However, in a multi-set, um, a multi-set can store duplicate elements. So a set automatically removes duplicates, right? It only stores one copy of each element, but a multi-set repeats elements as well. Siam, okay. So Siam, I just went through all of the containers. I can't realistically repeat all of them now, but I can share links with you later so you can look them up yourself. Okay, there are plenty of resources anyways given. Okay, so I'll just go over the problems right now. Siam, you can look in the DSA Learning week 3. There are a lot of resources there. Okay, or if you want, you can just, I'll put my number again in the chat. You can message me if you want about this. Okay, I'll put my number in the chat. So if anyone has queries, they can message me. Okay, yeah. So I'll move on now. Multi-map, I won't go over right now because it wasn't used in the week. But if you have time in the end, then maybe I'll go over it. But I'll start with the problems right now. Don't call right now, guys. So I'll start with the problems right now. Yeah, so the first problem I'm doing is this problem called Save Kahona, okay? I'll put the link in the chat right now so you can open the problem yourself as well. Okay, I've put the problem in the chat. So I'll just read the problem out. So Payne is the leader of a secret organization whose goal is to destroy the Leaf Village. After successive failures, the leader has himself appeared for the job. Naruto is the head of the village, but he is not in a condition to fight, so the future of the village depends on the soldiers, okay? So Naruto is a strong leader who loves his villagers more than anything, but tactics is not a strong area. So he is confused whether they should confront Pain or evacuate. So we have to tell him whether he should confront Pain or evacuate. So Pain has a strength of S. So let's write this down. So Pain has a strength of Z, sorry, not S. Okay. Naruto has N soldiers under his command. So there are N soldiers. When a soldier, the power of the ith soldier is AI. So when a soldier attacks Pain, his strength gets reduced by the corresponding power of the soldier. So when the ith soldier attacks Pain, pane's strength, which is z, becomes z minus ai. Okay. However, every action has a reaction, so the power of the soldier gets halved. Okay, so ai becomes ai divided by 2. Okay, so each soldier can attack any number of times, including 0. So pain is finally defeated when his strength becomes less than or equal to 0. Pain is defeated when his strength becomes less than or equal to 0. Okay, so we need to output the minimum number of times soldiers need to attack so that the village is saved. Okay, so in problems like these, when they ask you to minimize or maximize something, there are usually two possible approaches. Okay, there's either DP or greedy. Now, the DP, we haven't done DP yet, so I don't want to look into depth, but the only solution would be something like DPZ, um, and the constraint on Z is 10 to the power 8, so this will never pass. So let's look into greedy. Okay. Now, how we would approach a greedy problem like this would be, we would find an optimal approach to defeat pain. Okay. And here I'd say that the optimal approach would be that the soldier with maximum power attacks pain. Okay. Then his power becomes half. Okay, so it gets divided by 2. Now the soldier with the new maximum power attacks pain. Okay, now this process is repeated until all soldiers have strength 0, that is soldiers have lost, or pain has strength 0, soldiers have won. Okay, Shekhar, is recursion also part of greedy approach? I mean, it can be part of the greedy approach, but in this case, we won't need. MKV Kishore, can you repeat why DP never passes? I said DP won't pass in this case because any DP would require too many states, and the constraints anyway is quite large, so definitely won't pass. Okay. So I would say that this is an actually greedy approach that would work. So now the question is, how would we implement this? Okay, so we need a data structure where we can, number one, find the maximum element in order of 1 or order of log n. Okay, remove the maximum element in order of 1 or order of log n, and insert a new element in order of 1 or order of log n. Now, there are two data structures. Okay, and can store duplicate elements. Now, the only data structure that can do this is, or the most convenient data structure can do this is priority queue, right? Akshay, yeah, set would be kind of fine, but unfortunately, a set won't store duplicate elements, and multi-set is just overkill for this. So I think priority queue would be the best option here. So let's try to code this, okay? So let's see the input format. So there are t test cases. Okay. So while t minus minus, it's the same as writing something like, okay, it's the same thing. T minus minus is just more convenient, right? So that's why I use that. Then I'm just taking input of everything. right? So n is the number of soldiers. Z is the strength of pain, and A is the power of soldiers. Okay. Now let's say int answer is equal to 0, and let's keep a priority queue. Now it would be a max priority queue, right? Because we only need the soldier with the maximum strength, right? So pq.push AI, I'm just inserting all of the soldiers' powers into the priority queue. Okay. Let me look at. Yeah, Shekhar, we can use fast IO if you want. I just don't have it in the template right now, but yeah, we can use it. Okay, so we insert the elements into the priority queue. Now we need to run a loop, right? What are the constraints of the loop? I've written it here on line 24. The process is repeated until the soldiers have strength 0, okay, or pain has strength 0. So we can say while Z is greater than 0, and the other constraint is all soldiers have strength 0, right? So this can also be written as the max strength of any soldier is 0. So we can say PQ dot top is greater than 0, right? Now let's move forward. So int attack is equal to PQ dot top. So this is the strength of the attack. Okay. So can you tell me why did we use priority key here? Okay, so Sayam over here, if you look at the greedy approach I mentioned, um, what we have to do is we have to keep picking the soldier with the maximum strength, and then we have to attack pain with that soldier, right? So if we were to look at this in code terms, we have to keep on finding the maximum element in a container, taking that element out, and then pushing the element of half value. Okay. So I wrote the requirements of that data structure here. We did data structure. We can find the maximum element in order 1 or log n. So priority queue can do remove the maximum element in order of 1 or log n. Even this priority queue can do insert a new element in order of 1 or log n. So priority queue can do this. And finally store duplicate elements. And this also priority queue can do. So the priority queue just fulfills all of our requirements. So that's why we're using it. Right, thanks, Shubham. Okay. So this is the strength of the attack. Okay. So now Z is equal to Z minus the strength. If you see, I've written it on line 13 that the strength of pain gets reduced by the power of the soldier. Okay. Then we need to remove this element from the priority queue, right? Because we have used this attack power, we can't use it again, so we have to remove it. And now the power got halved, right? So we need to put attack divided by 2 into the priority queue. Okay, does that make sense? Okay, now we need to actually keep count of the answer as well. So I'm just going to keep oh, we have already declared a variable. So every time we attack, I'm incrementing the answer. Okay, now the problem states that if pain cannot be defeated, that means all the soldiers have run out of energy before pain. Then we output evacuate. Otherwise, we output the minimum number of times. So if Z is greater than 0, which means pain was not defeated, we output evacuate. Okay. Otherwise, pain was defeated, so we output answer. Okay. So I think this code is accurate. I'm just gonna try it once. Right. So 2 is the answer that's given for the sample test case, and we're getting 2. So I'm going to submit this, all right? Yeah, Pradeep, the new line, please do share submitted link. Yeah, Shubham, I'll just share it in a second. So Pradeep, yes, the new line operator would also be fine. In fact, the new line is recommended because, okay, so do you guys know the difference between new line and Endl? I'll just tell you. So the difference is that Endl flushes the output every time, which means that whatever the output is, it like it actually pushes the output to the console, and new line adds a new line to the output, but does not flush it. So Pradeep is right. New line is actually faster and Endl is slower. But it's just a habit that I use Endl. But yeah, you can, if it's a tight program, then you should use new line definitely. Thank you, Pradeep. And yeah, that got correct answer. So let me just share my code for this. Um, okay, guys, I've put it in the chat. Okay. Yeah, thanks, Adhan. Okay, now let's move on to the next problem. Yeah. So exon C. Okay. So it's this problem, right? So I'm going to read this problem. Let me just clear the IDE. Okay. So you're given an array A with n positive integers. So n is the size of the array, and right, okay, and it stores positive integers. Right. So a partition of the array into subarrays refers to dividing the entire array into subarrays and the subarrays are of continuous elements such that each of the n elements is in exactly one subarray. So we are dividing the entire array into subarrays. We call a partition of the subarray into of the array into subarrays valid if this condition holds true. For all I, if I and I plus 1 are in the same subarray, then A of I plus 1 must be divisible by AI. Okay. If I and I plus 1 are in the same subarray, then uh, okay, then AI plus 1 mod AI must be equal to 0. That is, it must be divisible by AI. Right? Does this make sense? Um, Pallavi, have we made submissions for the learning contest open? Okay, guys. So I don't know if you can access it. So just to be safe, I'll paste all of those codes into an online ID and I'll share the link. Okay. I'll share it at the end of the session, right? So let me continue with this. Okay, so we have to divide the entire array into n subarrays, and for two elements, consecutive elements to be in the same subarray, uh, the second element has to be divisible by the first one. Okay. Now, among all valid partitions, we are interested in the partition with the minimum number of subarrays. It can be proved that there is a unique such partition. Fine. So let's call Si the index of the subarray in which the ith element lies. Okay. Great. Now we want to support some operations in the array. In particular, there are queue operations in the firm. Okay, so this is a query problem. So there are queue queries, and let me just see what queue is. 10 to the power 5. Okay, fine. 1ix. Okay, so this operation is changing ai to x, and the second type of operation is output the smallest j. Okay, okay, fine. So the second one is a query in the form 2i. We have to output the first element in the same subarray as I. Okay, does this problem make sense? Shekhar, no, we won't be using segment. I mean, maybe you could use segment tree, but right now I don't think we need to for this problem. But okay, actually there is a segment tree solution, but I won't go over it right now. Okay, there's a much easier solution as well, I think. So right now there are q queries, 1e5, sorry. Okay, 2e5 queries, and n is 1e6. So the required complexity is either order of q or order of q log n. Okay. Now this problem takes a few tricks. Okay. Now there's a statement in the problem which says, among all valid partitions, we are interested in the partition with the minimum number of subarrays. Now this might seem complicated, but it's actually a very simple process. So in this problem, we have to form continuous subarrays, right? Now, for any index I, if ai plus 1 mod ai is equal to 0, then we should place I plus 1 and I in the same subarray. So this is the only constraint that we need to follow. And if we follow this constraint, then the number of subarrays will be minimized. Okay. Does anyone have any queries regarding this? I mean, this is the only constraint regarding formation of subarrays. So we should stick by only this constraint and try to minimize the subarrays, right? Okay, so I'll assume this is clear. Now, how do we do this? Okay, now first, more importantly, how do we store the partitions of the subarrays? I would say that since the subarrays are all contiguous, we only need to store the first element of each subarray, right? So let's say we have a vector, okay? So we have a vector called subarrays, and we have an array, let's say 2, 6, 5, 10, 15, 3. Okay, this is our subarray. This is our array, sorry. Now our subarrays for this should be 2, 6, 5, 10, 15, sorry, not 15, 5, 10, 20. Okay, it should be 5, 10, 20 and 3. Okay, these are our subarrays. Now we need some way to store this efficiently. So I'd say that the best way to store it is to simply create a store index of the first element of each subarray. Okay, so I'd say subarrays dot push back 0, which is the index of 2. But the problem takes 1 based indexing, so let's do 1 based. Okay, then the index of 5 is 3, and the index of 3 is 6. Okay, so our subarrays array is now 136. Now this implies that the first subarray has 1, 2. Okay, the second subarray has 3, 4, 5, and the third subarray just has 6. Okay, is that clear? Right, Pradeep, even a pair begin end is fine, but this representation is best, especially for the problem we're doing right now. Num name n. Okay, we haven't discussed the approach yet. I'm just discussing some prerequisites. So, okay, I'll tell you the prerequisites again. So the minimum partition, we have to find the partition such that the number of subarrays created is minimum, right? And for to create that partition, this is the only constraint. That if, let me condense this actually. If we can place AI and AI plus 1 in the same subarray, then they should be in the same subarray. Okay. And now we're discussing how we should actually store where the subarrays are partitioned. And we've decided that to do that, we'll simply store the index of the first element in that subarray. Why 15 was removed? Okay, Sumant, I removed 15 because if I kept 15, then 15 and 10 wouldn't be in the same subarray. The subarrays would be like this. Does that make sense? Lovely. So let me go back to 20. Now, for the second type of query, we need to output the first element of the subarray of index k. Okay. Now, what have we learned from our form of storing the subarrays? It's that 1 is actually storing the subarray of 1, 2, 2, 3, give it, of 1, 2. 3 is actually storing the subarray of 3, 4, 5, and 6 is storing the subarray of only 6. So for any element k, the first element in the subarray of element k is, let's call this SA, okay? The largest element in SA, largest element j in SA, such that j is less than or equal to k. Does that make sense? Okay, Devansh, is only 3 be counted as a subarray because it has not I plus 1th element? 3, yes, 3 is count. 3 is a lone subarray because it only has 3 itself. It doesn't have the I plus 1 element. You're right. That's right, Devansh. Okay. Now, does this make sense? For any element k, the answer for the kth query is the largest element j in SA such that j is less than equal to k. Devansh, why are we counting it, talking about 3? Because 3 is still a subarray on its own, right? Yeah, Devansh, because 3 is still, like, even single elements are counted as subarrays. Okay. Now for this problem, we need a data structure that can store elements in a sorted order, erase elements in order of 1 or order of log n. Okay. And Yeah. Find the largest such a j is equal to k in order of 1 or order of log n. Okay. Now, can anyone guess what data structure we'll be using for this? Yeah, Shekhar, we're still connected. Yeah, Neil, you're right. It's set. Okay. So we're going to use set for this problem. So let me change this vector to a set. And I'm going to store it globally. You'll see why later. Sorry. Okay. So let's start coding this. So the first thing I do is input nq, then a, then q. Okay. So I'm just inputting all of the requirements for the problem. Okay. Now we need to create the subarrays. So first note that 1 will always be the start of some subarray, right? Because 1 is the first element, there can't be any other element that starts the first subarray. Okay. Now this is how we'll go about it. If um, um, okay, so these two constraints, we're going to use this constraint here. Okay. So if ai mod ai minus 1 is equal to 0, right? That means we can place I and I minus 1 in the same subarray. Then we just continue, okay? Because we skip because we have already stored the start of the I minus 1th subarray, okay? Else we do subarrays dot push I. Sorry, insert. Okay, does that make sense? Pradeep, it's a for loop in the if, but it's a for loop, so we're anyways incrementing. We don't need to do the if. Okay. So in this way, what we've done is we have created the basic partitions before any queries took place. Okay. Now let's do the queries. Okay, before we do the queries, we're going to define a function where we say int find answer int x. Okay. Yeah. So this is going to handle the second type of query, in which we need to find the first element of the subarray of which x is a part. Okay. And the logic for that is we need to find the largest element j in subarrays such that j is less than or equal to k. Now we can do this by, how about we do this? Find the first element j such that j is strictly greater than k, and then simply do j minus minus as in the previous element. Does that make sense? Numen using bounds, correct. Excellent, guys. We'll use upper bound. You're right. So auto it, I'll say, is subarrays dot upper bound x, and then all we do is it minus minus and return the element at position it. So we've created a find answer function. Okay. And now let's just create a remove function. And oh, this is kind of redundant, but it's just this subarrays dot erase x. Okay, does that make sense? Guys, do you understand the remove function? Yes. Okay, then I'll continue to the answering queries. So queries are given in this form. So int type and index. Okay, so if the queries are type 1, otherwise do this. Okay, so if the queries are type 1, then we're changing the value of the ith element. Let me just make it ith for simplicity. Okay, so I'll input the new AI not AI. Okay, the updated value of AI. Okay, now there are 4 things that can happen. Okay, AI and A minus 1 can now be in the same subarray. AI and A minus 1 can no longer be in the same subarray. AI and AI plus 1 can now be in the same subarray, and AI and AI plus 1 can no longer be in the same subarray. Does that make sense? Shekhar, segment tree is quite advanced for this lesson. So we look at segment trees in the coming weeks, not right now. Okay. If you want to ask about segment trees, then I've put my number in the chat above, so you can message me. So Manth, why the remove function was added, I'm discussing that right now. It's for this query only. Okay. Now let's say AI and A minus 1 can now be. So if find answer I is equal to I, this means that AI and AI minus 1 were not in the same subarray. Okay. And first, let me just do this, because for the first 2 operations, I has to be greater than 1. Okay. So if this is the case, it means AI and A minus 1 were not in the same subarray, right? Now, if they weren't in the same subarray, but now because of the new element, because of the new value, I'm so sorry, AI mod AI minus 1 is equal to 0, which means that now they can be in the same subarray. So what we should do is, what happened? Okay. 1 second. Right. Okay. So which means that now AI and AI minus 1 should be in the same subarray. Now we need to reverse an operation, right? We need to reverse the operation by which we separated AI and A minus 1, AI minus 1. So look at our construction algorithm, okay? If you see over here, line number 68, when AI and A minus 1 and A minus 1 could not be in the same subarray, we inserted I into the set. Okay. Now we need to reverse this operation. Okay. We need to, okay, 68. We need to reverse the operation on line 68. So on line 68, there was an insert operation, right? So now we need to do a remove operation. So to do that, all we have to do is remove I. That's it. Okay. Now, this is done. Now let's look at the second type. Now AI and A-1 can no longer be in the same subarray. So if um, find answer I was less than I, which means that the subarray of I started earlier, okay? Which this means that AI and I-1 are in the same, were in the same subarray, okay? And AI mod A-1 is not equal to 0. So earlier they were in the same subarray, but now because the values have changed, they can't be in the same subarray anymore. Okay, just give me 1 second. Okay, yeah, so now they can't be in the same subarray. So now we need to perform the operation on line 68 to separate the elements. Okay, and the operation line 68 which separated elements was to insert, right? So we insert I. Okay. Now, these are the first two operations done. Let's look at the last two. Now, for the last two, there has to be an I plus 1. So this means I is less than n, right? Now, if find ans I plus 1 is greater than I, and I'm just copying this condition, okay? I plus 1 is divisible by I. So this means that the I plus 1 elements and the ith element weren't in the same subarray, but now they can be in the same subarray. So we have to merge those elements. And again, to merge it, we just have to perform the reverse operation of line 68. And so we'll just do remove I plus 1. Okay. Yeah. Now I'm going to do this. We have completed the third operation as well. And now for the final operation, it's find ans of I plus 1 was less than equal to I. So I and I plus 1 were in the same array initially. But now, after we change the values, I plus 1 is no longer divisible by AI. So we need to separate the subarrays. And to do that, we just do the line 68 operation and insert I plus 1. Okay. So we've handled the type 1 queries. Okay. Is that clear to anyone? If anyone has a doubt, you can bring it up in the chat. Okay, then I'll assume it's clear. So I'm gonna handle the type 2 operations now. So for the type 2 operations, we just need to output the leftmost index. So all we have to do is output find ans I. Okay. So this is the both of our operations complete. So let me just test it now. So our output is 133, which is the sample output as well. So our code is working. So I'm just going to submit this. Or did anyone have a doubt? Or if it's clear, then you can just write that. Okay, right. So again, this was the correct answer. So yeah, again, I'll upload this to some ID after the session. So I'll move on to the next problem now, which was C vote, which is a map problem. Okay, so C vote, chef of the year. So chefs from all over the globe gather each year for an international convention. Each chef represents some country. Please note that more than one chef can represent a country. Each of them presents their best dish to the audience. The audience then sends emails to a secret and secure mail server, with the subject being the name of the chef of whom they wish to elect. So you will be given the list of subjects of all emails. So find the country whose chefs got the most number of votes, and also the chef who got elected as chef of the year. So we need to find the country with the max votes and the chef with the max votes. Okay, and we if there's a tie, then we separate it by the lexicographically minimum answer. So let's try this. Okay, fine. So let me go back to the IDE. Oh shit, Naman, you want to walk through type 1? Okay. I'm sorry, I didn't mean to say that. Okay, so the type 1 operations. Okay, so Naman, do you understand this part that there can be 4 different operations? The first operation is that I and I minus 1 were in the same subarray, and now they have to be changed. The sorry, the type 1 operation was that they weren't in the same subarray, but now they can be. So the subarrays have to be merged. Okay. The second one is that they were initially in the same subarray, but now they have to be partitioned. The third one is that I and I plus 1 have to merge. And the fourth one is that I and I plus 1 have to partition. Now, if you see, our conditions for all are quite similar, okay? So the conditions are that for first checking if they are in the same subarray or if they're not in the same subarray. Okay, so this is what this one does, right? And the second one is checking that if the with the updated values, they can be in the same subarray or if they still can't be in the same subarray, right? So for each of those, we're checking that. And now the only complicated thing is to remember that a merge operation removes the larger index. Okay, that's what we're doing with this remove. And a partition operation inserts the larger index. Okay, is that understandable, Nauman? Okay, lovely. So I'm going to move on to the problem we were discussing just now, which was C vote, I think chef here or something like that. Okay. So for chef of the year, we need to output the name of the chef who got the most votes, as well as the name of the country that got the most votes. Now let's assume for a second that all of the countries and all of the chefs are represented by a number, not a name. Okay, they have an ID number. Okay, so then how we could store votes? So we could create an array that was simply called array votes. Okay, with length n or whatever. Okay, let me just write. Yeah. Okay, and we could simply do and whenever there was a vote for candidate X, we could do votes X plus plus. Does that make sense? And then we would simply have to find the max. Does that make sense, guys? You can be active in the chat. Okay, it makes sense. Unfortunately, we have names, not IDs. So n is not a number; it's a string. So we need a data structure that can use strings as a key and int as the value. Any ideas? Naman, that's right. It would be a map with string int. So let's use map string int votes. Okay, let's say chef votes is also country votes. Okay, map string int country votes. Okay, now let's look at the input format. So we're given two integers n and m. So I'm just inputting n and m, denoting the number of chefs and the number of emails respectively. Each of the following n lines contains two spaced strings, denoting the name of the chef and his country respectively. Okay, so that's how we find the country. So we need to create another map. Okay, and map x stores the country of chef x. Okay, does that make sense, guys? Okay, great. So I'm just taking input right now. Okay, and I'm setting country of chef is equal to C. Oh, I'm so sorry. Okay, now we need to store the max for both. So let's call string pair string int. No, bad idea. Mm, string max country. Okay, string max chef int country votes int chef votes. Okay, now let's go over all of the m subjects. So we're given the chef that they're voting for, right? They're voting for this chef. So we increase the votes. Okay, so chef votes for this chef become higher. What happened? Okay. Um, okay, so chef votes for this chef becomes higher, and country votes for the country of this chef also becomes higher. Okay, now if chef votes for this chef is greater than um, max chef votes, then we say max chef is equal to chef and max chef votes is equal to the votes of this chef. Okay, else if, and this is an important part, the chef votes for this chef are equal to the max chef votes, then max chef is equal to minimum of chef and max chef. Okay, and now we need to do the same for the country. Yeah, Shekhar. So we need to do the same for the country, right? So if country votes of the country of this chef is greater than max country votes, then max country is equal to the country of this chef and max country votes is equal to this. And if they happen to be equal, I'm just copy pasting because they're long variable names. If they happen to be equal, then max country is equal to min of country of chef and max country. Do you guys understand why we're taking the min operation? Because we need to choose the lexicographically minimum one. That's the reason for the min operation. Okay, and at the end we just have to output um, the country and then the name. So max country Endl and cout name Endl. Oh, sorry, cout max chef Endl. Okay, I'm gonna try to run this against this input. Now Italy Ramanujan is the output we've gotten, and that is the correct output as well. Let's try it with the second input. Now England Euclid is the output, and that's the correct output. Let's try to submit this. Please repeat after for loop. Which for loop do you mean? Do you mean this one, the for loop for M? So you want me to repeat what I'm doing inside the loop? Is that right? Okay, great. So what I'm doing is that we've received what chef has received a vote, right? So chef has received a vote. So here we're incrementing the votes for chef, okay? And here we are incrementing the votes for chef's country, okay? Let me just check in. Okay, yeah. So we're incrementing the votes for chef's country, right? Now, if chef has exceeded, if chef's votes has exceeded the previous max votes, then set max chef to chef and set max votes to chef votes, okay? And the other option is if chef's votes have become equal to previous max votes, okay, then I mentioned this earlier that if two chefs have equal votes, then the tiebreaker is the lexicographically smaller chef. Okay, so we're just tie breaking here, and we're doing exact same operation for country. Okay, and finally we're just outputting the maximum votes country and the maximum votes chef. All right, does that make sense? Rishabh, did you understand? Okay, lovely. So then we'll move on to the last problem, which is sub-Pranjal. Okay, good name. Sub-Pranjal. So yet again a subarray problem. Okay, so you're given an array a1, a2, an, and an integer k. For each subarray s, oh, so it's contiguous subarrays. Okay, let me just write this down. You are given an array a of length n. Okay, you have to consider all contiguous subarrays. Okay, and yeah, okay. N is less than equal to 2000. So order of n squared is possible. Okay. Now let's look at the problem. So let's define B as S concatenated. Concatenated. Do you guys know what concatenated means? Oh, I'm so sorry, Shreyas. Can we do this by any other data structure? I guess you could use unordered map, but we need the key to be strings. We need the key to be strings, so you could hash it and do it with int. Okay, but that would become very expensive. So I'd still say that map is the best. Okay. Do you guys know what concatenated means, or should I explain? If anybody doesn't know, then they can put. Shekhar, no, you don't know. Shekhar, I need to. Okay, need to explain. Fine. So let's say you have a string s is equal to abc, then concatenate means to add something to the end. So if we had to concatenate S to itself 5 times, okay, 2 times, we would get ABC, ABC, ABC. Okay, does that make sense, Shekhar? So if we had an array 1, 2, 3, and we have to concatenate it 3 times, let's say, so it become 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, got that. Lovely. Okay. So let's define array B as S concatenated with itself M times, where M is the smallest integer such that M multiplied by the length of the array is greater than or equal to K, and K is given as input. So K is given as input. Oh, I'm sorry, I removed a lot of good stuff. Okay. Okay. Now let's try to find the formula for M. Okay. So M multiplied by length of array is greater than or equal to K. Okay. So M is equal to ceil K divided by length of array. Okay, just keep this in mind. Okay. Now let's sort B and define X is equal to the kth smallest element of B. Okay. X is equal to kth smallest element of B. Okay. Now F is the occurrences of is the frequency of X is the frequency of what? Of X in S. The S is the original subarray before concatenation. Okay. The subarray S is beautiful if F also occurs in S. Okay. Now in this problem, there's no obvious trick to make this faster. So we just need to do this for every subarray and manually add this to the answer. We need to output the number of beautiful subarrays. Okay. Right. So remember I said that order of n squared is possible because the constraint for n is quite small. So the only our option here would be to consider all subarrays. Okay, so let me first take the input and then I'll explain. Okay, now let's go over all of the subarrays. Okay, this is a standard loop I'm making. Okay, so this is a pretty standard function. It's just a standard loop. It's just going over every subarray, iterating over all subarrays. I plus 1, I plus 2, dot 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 j. Okay. Now there are a few things we need to do. We need to keep track of the number of the frequency of the elements in the subarray, right? So to keep track of the frequency, I'm going to use a map. Okay. Now, okay, X is equal to kth smallest element of B. So we should try to condense this a little bit. Okay. So the kth smallest element of B would be the ceil of K by mth smallest element of S. Does that make sense? Let me give you an example. So let's say we have a subarray 1, 2, 3, 4, 5, and m is equal to 2. Okay. So B is equal to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay. Okay, Shekhar, I'll share some tips at the end. So this is the subarray B. Now let's say we need to find the ninth smallest element in B. Now the ninth smallest element is obviously 5, right? But let's say we want to find in terms of S. So using this formula K by M, we would find that seal of 9 by 2 is equal to 5, right? And the fifth smallest element of S is 5 again. So this is the formula we need to use, because constructing the array B, the subarray B, will become way too expensive, right? So we should try to do everything in terms of subarray S, not B. Okay. So int yeah, int m is equal to, I had defined it here, seal k by length of array. Seal double, I'm sorry, we have to input k as well, right? Ln k, yeah. K divided by length of array, which is j minus I plus 1. Okay. We found m, and now we should also find we should also change the k, right? So int k1 is equal to seal double k divided by m. Okay. And now I'm going to do k1 minus minus because we use zero based indexing. Okay. Now this is the tricky part. We have a subarray I to j. Okay. How do we find the kth smallest number in order of 1 or order of log n? Does anyone know how to do this? Can anyone give a data structure? Sorry, Rishabh wants line 18. Line 18. Okay, yeah. So we have a subarray S, which is 1, 2, 3, 4, 5. Okay, and we have it concatenated 2 times. Okay, so we've changed S into 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. Okay, now we have sorted S, and that's our subarray B. Okay. Now let's say that we had to find the ninth smallest element in B. Now our subarray, our array B can be very, very large. So instead of doing it in B, I want to find what element it would correspond to in S, right? Okay. So the kth smallest element in B would be the yth smallest element in S. What is Y? And we found that Y is equal to seal of K by M. Okay, does that make sense? Okay, great. Chain sync, priority queue. No, unfortunately, a priority queue won't work for this because a priority. One second, Shekhar. So a priority queue can give us the largest element in order of 1, but to find something like the kth largest element, it would still take order of k. Okay, and that's too expensive. And Shreya's audit set. That's brilliant. That's the right answer. So I'm gonna do this. Okay, I'm gonna maintain an audit set. Audit set S. Okay, and this is an audit set of pairs. Okay. So I'm going to insert into the audit set s dot insert, and I discussed how to store duplicates in a set, right? So we insert the element itself, which is equal to aj, and we insert the frequency of j plus plus. Okay, that's how we do it. Now we have to find the k1's biggest element. So we do auto it is equal to find by order k1, okay, and the element is equal to star of it dot first. Okay, now what we have to do, f is the frequency of x in s, so the frequency is equal to frac of element. Now the subarray is beautiful if the frequency also occurs in s. So if frac of frequency is greater than 0, then subarray is beautiful. Okay, so let's say we have int answer is equal to 0, so we can just do answer plus plus here, and at the end I'll just output answer. Let me just try this with the sample case. Three. Okay, so it seems to be working. Let me just try to submit it. How was m calculated in line 37? Okay, so let me just go back. I'm opening the problem. Okay, so if you see, m is the smallest. R minus L plus 1 is simply the length of the array, right? So R minus L plus 1 has been replicated with J minus I plus 1. Okay, and wrong answer. Okay, in a second. Let me just try to find a bug. K is equal to ceiling of K by M, which is fine. K1 minus minus, because we use zero-based indexing, also fine. Now we're inserting AJ and frequency of, oh, I'm so sorry, frequency of AJ. This might be the bug, so I'm just submitting it again. Someone give me a second, I'll just explain how M was calculated. Let me just try to get the right answer on this, then I'll explain it. What? Okay, we got partially correct answer, but we're still getting TLE. Okay, so I think we're getting TLE because map still has a log factor. So I'm just gonna have to change that. Let me look at this. Okay, so AI is also less than 2000. Fine, so we can do this. So let's make int frequency 2001. Okay. Okay. Then again, I'm just making small optimizations. And I'll use fast IO. Okay. Naman, is it possible to go through this once? Yeah, sure, Naman. Give me a second. I'll just submit this once and I'll go through it again. Yeah, this is a complicated question. So let me just try to get the right answer and I'll go through each line of code. Right. Okay. So yeah, this is the right answer. Let me go through the code. So someone asked, how is M calculated, right? So let's go back to the definition of M. So M is basically equal to, M is the smallest integer such that um the size of the array multiplied by M is greater than equal to K. Okay. So M multiplied by length of array is greater than equal to K. Look at line 13, guys. So M is equal to K divided by length of array, right? And if it's not divisible, then M will be reduced. If not divisible, C++ will automatically take floor. However, in that case, M multiplied by length of array will be less than K. So we need to take ceil. That's why M is equal to ceil of K divided by length of array. Okay, let me give you an example here actually. So let's say that K is equal to 3 and length of K is equal to 5 and length of array is equal to 3. Okay, then if we didn't do ceil, if we just did K divided by length of array, then M would be equal to 1, right? And if you see 1 multiplied by 3 is less than 5, so it's inaccurate. But if we do ceil, then ceil of 5 divided by 3 is equal to 2. And 2 multiplied by 3 is equal to 6. And 6 is greater than length of array. Therefore, M is equal to ceil of K divided by length of array. Okay, does that make sense? Okay, great. So now you guys want me to go through the you know what, Naman, can you just tell me where the doubt is, or if you want me to go through the problem again, I can do that. Chain sync in these things, sync with studio and all are just making the input faster. So in Java, I think you can create custom input class which is faster, but this exact thing isn't there in Java. Okay, so if everything is clear, then I'll end the session right now because that's all we had planned. But if anyone has any doubts about this problem, anything we discussed today or CP in general, anything they can ask right now. Link for the submissions, right? So I'll right now only I'll paste the submissions into an IDE, and I'll put the IDE up on. I'll put the links up on discuss, okay? Or maybe I'll link it to my own blog, something like that. Okay, I'll put it up on CodeChef. Don't worry about that. Rishabh Raj, you want me to solve the first question? Okay, I'll do that. So you want me to solve depends, is that right? A chain thing, it's up on YouTube, so you'll be able to do that. Sumant, when I identify bugs, there are a few things. So one tactic is just that in every loop, you keep on outputting whatever values you're using, and then you can write down the problem yourself. So whenever the values don't match, you can find the source of the bug there. And in this case, I just analyzed the code and looked for problems in my own implementation. But I mean, debugging is something that comes with experience. It's not such a hard skill. Okay, hard look for corner case. Okay, I'll just explain that after I'm done with dpairs. Okay. So chef has two integer sequences, a1, a2, a3, an, and b1, b2, b3, bn. you should choose n plus m minus 1 pairs such that the sums are all pairs-wise existing. And you have to output the pairs. Okay. So, acha, theek hai. So, Rishabh asked for it. Is that right? Yeah. Okay. So, Rishabh, in these type of problems, there are two approaches, right? There's a comparative approach where you pair each element in A with each element in B and then check for unique sums, right? Now, Shekhar 2-pointer. Okay, Shekhar, again, you can do 2-pointer, but right, there's a trick here, okay? So there's this comparative approach. However, this kind of approach will always be at around order of n square. You can use some very advanced data structures and logic to try to reduce this, but it's a huge overkill, okay? Now, in these kind of problems where it should clearly TLE, you should look for hints in the problem statement. Now, the only hint that we have here is this is very odd, right? They want us to find n plus m minus 1 pairs. Now, why could this be? In most problems that want a comparative approach, they could just give the requirement as input, right? So this implies, because they didn't give it as input, it's a big hint that n plus m minus 1 pairs is very important in the logic of our program. So this is kind of an observation, okay? So you have n elements in A and m elements in B, okay? Sort both A and B. Now, it's very hard to think of this like it's a completely observation-based problem only, but this is what I would do. Pair the first element in A with all elements in B. So we have m pairs, and then pair the largest element in B with all elements in A other than first one because already used, okay? And this will result in n minus 1 pairs. If you add both, then you get m plus n minus 1 pairs. Does that make sense? Rishabh, does that make sense? It will take n squared. Why did you choose the largest element in B? Excellent question. So I'll tell you why. So let's say we have two arrays, 3, 6, 8, and 2, 5, 9. Okay. Now we have in the first step we took 3, 2, 3, 5, 3, 9. Okay. Now let's think for a second that you know what, 3 plus 9 is 12. So let's make this 7 instead. Okay. So let's think that instead of taking the last element, let's take the second last element of B, okay, which is 5. So we'll skip 5C because that's already done. So you'll do 5, 7 and 5, 8, right? But there's a problem here. 5, 7 sum is equal to 12 and 3, 9 sum is equal to 12. So there's a conflict here, okay? And so there's a risk of using this element. However, if you choose the largest element of B, then keep in mind that the largest sum earlier was A smallest plus B largest. Okay. Now, the smallest sum of operation 2, this is the operation of 2, line 17 is operation 2, okay? The smallest sum of operation 2 is A second smallest plus B largest. So this means that even the smallest sum in the second operation is strictly greater than the largest sum in the first operation. Therefore, there is no overlap in sums. Did that make sense, guys? Sehaj, you asked the question, right? Did that? Okay. So, do you want me to implement this? It's very direct, or will you just do it? I can implement it if you want. Guys? No, you don't mean. Okay, you can do it, right? Okay, great. You had any other question, guys? Corner case. Okay. So usually corner case happens in okay, I'll tell you. Corner cases are generally cases where the basic assumptions of our problem, of our solution, do not hold. Okay, so I'll give you an example. How should I give the example? Okay, I can't think of any problem as such where there is a corner case. But okay, you guys have solved rectangles in ZCO? I did it in my last session. Have you all solved rectangles? It's in week 2 in the learning series. You solved rectangles, right? Okay. So in rectangles, the solution was based on the assumption that the top edge of the rectangle is bounded by a point, right? Using this assumption, we used our stack algorithm to find left-right bounds for each rectangle. However, there was an edge case, however, where this assumption was inaccurate, right? There was an edge case where the top of the rectangle was touching the plane. Okay, so this is how we find edge cases. We just check all of our assumptions and see if there are any case that violates those assumptions. Okay, Naman, how to do mod? Okay, guys, I don't want to take too long because I have to end this, and this is in different weeks, but I'll just tell you. Okay, so tricks for mod operation. Okay, a plus b mod m is equal to a mod plus mod is equal to a mod plus b mod. Okay, a minus b mod is equal to a mod minus b mod plus mod. Okay, and uh, multiplication is same as addition, and for division you need to find mod inverse. Mod inverse is basically okay, so guys, I don't want to get into this right now, but I'll just say, okay, mod inverse of b is b to the power mod minus 2 mod. Okay, so if you want to do a divided by b mod you is equal to a multiplied by b inverse mod. Okay, does that make sense? Guys, fast typing, I mean, it's just practice only. Like, okay, for all of this extra stuff you can message me. Guys, I don't want to exceed the limits of this session, so I'm just giving you my phone number right now. If anyone has doubts, you can message me right now. Okay, or right now or whenever you want. So I'm putting my number here in the chat. You can message all these extra doubts to me. Okay. You can use WhatsApp, okay? Cool. So I'm going to end this meeting now. Is that fine with everyone? Sehajbir, I'll just upload the submissions in a blog on CodeChef Discuss. Okay. And Devansh just message me and I'll answer your questions. Okay, great. So I'm gonna end the meeting.